This video is on section 2.7 and it is talking about a couple key theorems. The first one is actually pretty straightforward and easy and hopefully makes a lot of sense to you. It's called the fundamental theorem of algebra. And what it says, if you have a function f of x, it's a polynomial of a degree n, where n is greater than 0, okay, so you have to have more than just a constant, then the equation f of x equals 0 has at least one solution in the set of complex numbers, okay? So as long as you have something more than a constant, if you've got a polynomial of degree 1 or bigger, okay, you will have at least one solution to that. And the corollary to that is if you have a polynomial function of degree n, where n is greater than 0, then the equation f of x equals 0 has exactly n solutions, provided each solution repeated twice is counted as 2 solutions, and each solution repeated 3 times is counted as 3 solutions, and so on. So what that means is, you remember like when we had the quadratics, okay? And remember when we factored certain quadratics, we had the discriminant became 0. Remember when we looked at the discriminant and we said there's one solution because it was just touching the x-axis. So here's an equation, x squared minus 4x plus 4. It is a second degree polynomial, okay? According to this corollary, it should have 2 solutions because it's degree 2, okay? And if you count these as 2, it does have 2 solutions. So what it's saying is you can look at the degree of a polynomial and know how many solutions it has, how many complex solutions, by looking at the degree, as long as you can count these as 2. Because you can see if we factor this, we get x minus 2 times x minus 2 equals 0. So we have 2 numbers here, 2 and 2. The thing is they're the same number, so it's only touching the x-axis in one spot. So if we count those as 2, we can actually use this corollary to predict or to tell how many solutions we have. So here's a quadratic, okay? How many solutions, like we say, if we're counting the duplicates, does this have? Well, this is going to have 2 solutions, 2 zeros. If we set this equal to 0, we are going to have 2 zeros in the set of complex numbers. Okay, that's the key thing. This is a degree 3. So if we set this equal to 0, we are going to have 3 solutions in the set of complex numbers. Here is a degree 4 polynomial. We are going to have 4 solutions in the set of complex numbers. And that is all that theorem is trying to tell you. So you should know that you've got, if you're looking at a 4th degree polynomial, you've got 4 solutions. There could be some duplicates like this, but you're going to have 4 factors. You're going to have 4 solutions like this. Okay, and so you need to be looking for them. So if you look at a graph of a 4th degree polynomial and you only see that the graph is crossing the x-axis in 2 places, you know that you've got 2 real numbers. Okay, so let's say you graph this a polynomial in 4th degree and you look at it and it looks like this. Okay, you can see very clearly it's crossing the x-axis in 2 spots. Okay, but it's a 4th degree polynomial. It has to have 4 solutions in the set of complex numbers. So you've got 2 real solutions. The other 2 solutions have to be imaginary. Okay, so this is how you can tell by looking at the polynomial how many how many zeros you should have if you were to set these functions equal to 0. Okay,